Okay, this is chapter 3.3 about salt preparation. It is, I don't know if the quiz is enough, but guys, by the way, for sure, if you're studying, whether it's finals or periodic, make sure to do the notes. Solve all of these questions. Each and every one of them is very, very important. Okay, just put it there. Like all of these CQDs, if I'm not wrong, they should have their answers in the notes, shoe notes, as in the course division solutions. If not, they should be in your copybooks if you write. If not, then just ask on any group. Anyway, which of the following could be used to prepare soluble salts? Okay, you want uh, a soluble salt. This came in the AMS, and the answer was base with ammonium salt, acid with sulfide, and the last one was acid with carbonate. These were the answers in the CA. Okay, why some people got it wrong is because they didn't say metal before, and apparently it doesn't matter. I was one of the some people who got it wrong, but it doesn't matter if they don't put metal. The only thing you really care about is if they say carbonate. But see, this is wrong because they said base. It should be acid. The only one with base to get a soluble salt is I should find it somewhere here. Oh shit, this is English. Yeah, here. So to get a soluble salt, you have these reactions. Okay, acid plus metal, acid plus metal oxide, acid plus metal hydroxide, acid plus metal carbonate, acid plus metal this is sulfite, and then acid plus metal sulfide. Okay, and then ammonium salt plus base. These are the 7 ways to get a soluble salt. Okay, so acid metal is correct. It will get you hydrogen gas and salt. Acid base, obviously salt and water. Base upon sulfate, no, it should be acid with no, hatta sulfate is wrong. It should be sulfite or sulfide. Because with sulfate is SO4. We don't care about SO4. We only care about SO3, which is sulfite, or sulfide, which is just S. Okay? Uh, then acid upon basic metal oxide. Okay, whatever. We said metal oxides already. Question 2. The preparation of solid salts, so this is insoluble, involves a direct combination of two elements, a metal and a non-metal. Okay, solid salts. Any salt is an ionic compound made out of a cation and then anion, right? For example, the solid salt AgCl can be prepared by combining AgCl and silver as a HCl and let's say I don't know AgNO3. Okay, if you combine these two, you get AgCl. So it involves a direct combination of a metal Ag and a non-metal Cl, right? This is the precipitation method. Remember the precipitation method? This is a very famous combination. Okay, uh, AgCl is very famous, but basically for precipitation you mix two soluble aqueous solutions, even if they're an acid. Even if it's an acid, as long as it's aqueous, we don't care because you guys know acids and bases are also aqueous because you can dissolve them in water, right? So you mix two aqueous solutions to form one insoluble solution. How do you know if it's insoluble? From our solubility rules from chapter 2. I'm gonna pull them up now. By the way, if you're watching this for the periodic, this is also required, huh? The chemical analysis, so know them all, huh? So these solubility rules, you must know them, guys. All of these, okay? Because these are the ones, like, if it contains any of these, you should know then it's soluble, right? And these are always soluble except with Ag and Pb, right? SO4, because this came in the CA, they told you mix PbCl. They mix PB. Yeah, PbCl. They said mix PbCl for the precipitation method. No, this is already insoluble. You can't mix an insoluble to get an insoluble. You need to be soluble. Okay? And SO4 is always soluble except with these. And then these are always insoluble except with the big five, right? And then forget about the others. But this is just so you guys can know. Anyway, let's go back here. Question 3. Nitric acid, HNO3, reacts with potassium hydroxide, which is obviously a base, to give water and potassium nitrate, which is the salt, right? Drag and drop the correct item below to identify each of the following equations. If it's okay. You guys from grade 10, remember we did net ionic, overall non-ionic, overall ionic. Okay, overall ionic basically means split everything into ions. I'm gonna write them down on the side so you can kind of see. Overall ionic means write everything, okay? HNO3 is what? H plus and O3 minus. And aqueous, obviously it's aqueous because they're ions, okay? Potassium hydroxide is K plus, OH minus, again aqueous, aqueous. To produce H2O, what's H2O? It's not an ion, right? But we just leave it as H2O. Okay, and potassium nitrate. What's potassium nitrate? K plus and NO3 minus. Isn't this the same as this? There you go. This is the overall ionic. When you say overall non-ionic, basically means just write the reaction, bro. Mafi ions, you just write HNO3 plus KOH. These are my two reactants to form H2O and KNO3. Non-ionic, from the word non-ionic, Mafi ions. And then net ionic. Net ionic, if you want my advice, because I'm positive that you're going to be asked, I feel like you're going to get asked in your written part to write down a net ionic equation. If not written, definitely in the computer. And it came in the CA. For me, how I find the net ionic equation is I write it down like this. Okay? I always write my stuff down like this. Okay? I see which one changed its states. Okay? So I look here. H plus on both sides. Sorry, H plus here is aqueous. But here, what is the hydrogen? It's a liquid. So I'm going to put down H plus and H2O, right? Because it changed into H2O. NO3 is aqueous. So since it didn't change its state, I'm going to put a nice X on it. We're done from H plus, we're done from H2O. K plus is aqueous. So it didn't change its state, so we're not going to include the net ionic. OH was aqueous, but here the OH is actually part of H2O. Guys, for those of you who don't know, H2O is H and OH. Because 2 hydrogen, 1 oxygen. Okay. So this OH was aqueous, it started liquid. فsince it changed, شو حنعمل نحطه هون. Okay. And obviously aqueous, aqueous liquid. Okay. Basically, net ionic is that. It's usually very short. The shortest one is usually net ionic. It is that includes only the substances that participated in change of state. Okay. Question 4. Hydrochloric acid, HCl, reacts with potassium carbonate to give a salt, a liquid, and a gas. Okay. What is the salt? Okay, very easy. HCl, potassium carbonate. Acid plus carbonate, right? What's my acid? HCl. What's the carbonate? K2CO3. How do you find the acid? As the salt that's produced always fully box the middle. Full box. K2, you get no, just KCl. Because Cl is Cl minus, K is K plus, crisscross, you get KCl. This is your salt. What's this called? Potassium chloride, right? Please don't put potassium chlorine. Please, okay? It's an ion, so obviously IDE. Potassium chloride. What's the chemical formula? KCl, not K2Cl, KCl, right? How do you find always K plus Cl minus? I think everybody now should know how to get the charges of everything, right? From the periodic table, K is in group 1, Cl is in group 7. Group 1, yani charges plus 1. Group 7, it needs one more electron, so it's going to be minus 1. But we don't write minus 1, we just put minus. So K plus Cl minus, crisscross, you can get KCl. What is the gas that forms? Always when you're reacting a carbonate, what forms? CO2. And what's CO2? Carbon dioxide. What's its chemical formula? CO2. Well, okay, we just said it's CO2. Write the balanced net ionic equation for the reaction that takes place. Okay. If you want my advice, this came, by the way, this whole thing came. This was multiple choice, and this was, you had to type this out. I think here it comes like this. They want you to actually write it. Okay. I'm gonna go here. If you want my advice, always when you're reacting acid with carbonate, always, you're gonna have in your net ionic, you're gonna have H2O and carbon dioxide gas. Always. Okay? This is how it's gonna look. It's gonna be like this in the product. depending. So and you're gonna have H plus, and you're gonna have CO3 2 minus. It's always like this for reacting an acid with a carbonate. Always, always. Okay? But don't memorize. I'm going to show you easier. So you don't have to memorize. Always, when you want net ionic, you want to see what changed. How do you know what changed? You write it down. Okay? HCl, obviously it's aqueous. All acids and bases are aqueous. Unless they specify otherwise. Unless they say it's liquid HCl or something like this. K2CO3, again, if it's a carbonate, if they don't mention it, it's aqueous. Okay? If they don't mention it, it's just aqueous. Okay, unless they say solid or lumps. Lumps means solid or gaseous. I don't know. To give a salt, akid the salt, we know what the salt is, right? We said it's KCl, right? And then obviously the salt is aqueous, right? All salts are aqueous unless you're doing the precipitation method, which forms a solid insoluble salt, right? Okay. A liquid, we said the liquid is H2O, right? It produces water and the gas, carbon dioxide gas. What do we see? We check which one changed its state. Let's see. Hydrogen, aqueous. What did it turn into? H2O, which is liquid. So did hydrogen change? Yes. So you take down hydrogen and you take down H2O. Liquid, this was aqueous. In the exam, they did not ask for state symbols. They specifically said don't write state symbols. Chlorine here was aqueous. Chlorine here is aqueous. We're done from this. We're done from the chlorine. K2 was aqueous. K is aqueous. It didn't change. CO3 is aqueous, so the carbonate was aqueous. It changed into carbon dioxide gas. So did it change? Yes. Are we gonna include it? Yes, we're gonna include it. I included H2O, so I should cross it out. So plus CO3 2 minus, which is obviously aqueous, turn into carbon dioxide gas. There you go. Okay. The charges you must know. Sasa, they said the Banets. It's H2, so I have to put a 2 here. And then other than that, it's balanced. The charges, you must know them, guys. It was given in the exam. In the exam, how did they give it? They did this. تقريبا the same thing. But they just, without the state symbols, like here they put this for you. And they put the arrow and they said like continue it. So you had to put CO2 and H2O. That's it. That's how it came in the exam. Question 5. Sulfuric acid reacts with sulfite, SO3, to give a salt, a liquid, and a gas. How I memorize it? Sulfite is SO3, right? It's the same as the carbonate CO3. Don't they look the same? It's just instead of C, you have S. So it's the same exact reaction. When you react with a methyl carbonate, you get carbon dioxide gas, and you get water, and you get the salt, صح? Salt. Right? It was in our rules. And at this point, guys, I'm going a bit fast on them because, guys, we've done maybe 2 AMSs on them. خلاص, you guys should know them. Any reaction with the carbonate gets you this. So with sulfite, sorry, it's the same thing, but instead of C, just write S. So instead of C, we're going to write SO2 gas, and the rest is the same. Okay? The acid plus, akid. Metal carbonate, metal sulfite. Okay. Sulfite, with an I. Sulfite with an I is SO3. Sulfate with an A is SO4. Okay, we don't want SO4, we want with an I, SO3. Okay, so you get this, right? This is our reactions with the sulfite. Type. Let me erase this. So, same thing, salt, liquid, gas. What is the salt that forms? What do? We write down acid plus sulfite, H2SO4 plus Na2 SO3. How do you know the acid? Full box in the middle. You're going to get Na plus and SO4 2 minus, صح? We want to crisscross to know the acid, to know the salt. 2 goes down, so it's going to be Na2 SO4. Okay, this is my salt. What is this? Sodium sulfate with an A. With an A. SO4 is with an A. SO3 is sulfite with an I. And S is sulfide with a D. Okay, please, I'm going to write them down for you. Sulfate, SO4 2 minus. Sulfite with an I. SO3, I think it's minus. Or 2 minus. I don't know. I'm not sure. I think it's 2 minus. SO3. Anyway, this is what they are, okay? Just so you know how to write them in the exam. So, it's SO4, so we can say sulfate with an A. And give the formula, we just found the formula. Okay, give the name and the chemical formula of the gas that forms. What's the gas? We said it's reacting with the sulfite. So instead of CO2, like it was a carbonate CO3, now it's SO3, so it's going to be SO2 gas. And this is what, instead of carbon dioxide, it's sulfur dioxide. What else do they call it? Okay. And what's the formula? SO2. Then they say net ionic equation. By the way, same exact thing as the last one. But let me just write it the same way I did last time. You have H2SO4, obviously aqueous, with sodium sulfate and A2, sodium sulfite قصدي. I don't know why I keep on saying sulfate, which is also aqueous, unless specified otherwise. To give a salt, we said the salt is K, as they should K. It's Na2SO4, that's the salt. The liquid is obviously H2O liquid. I should have written aqueous here, because salt is always aqueous, unless it's insoluble. Plus the gas we said is SO2. Let's see. Hydrogen was aqueous, became hydrogen liquid. So obviously we're going to put H plus, H2O, liquid. And this is aqueous. طيب, done. Done. SO4, aqueous, hon, aqueous. We don't want it. Na, aqueous, Na, aqueous. We don't want it. SO3 was aqueous, SO2 became gas. So did it change? Yes. So we're going to put SO3, aqueous. 2 minus, huh? Gas, so SO2 gas. Just like this. This is net ionic, because we saw what changed. Question, how many questions is this, man? 11? Okay, oh my god, this is the same question over and over again. Okay, potassium hydroxide KOH reacts with ammonium nitrate to give a salt, a liquid, and a gas. This is a base. This is ammonium salt. The reaction between a base and ammonium salts produces a salt, water, and ammonia gas. Okay? What is the name of the salt that forms? Base plus ammonium salt, KOH plus NH4 NO3. Box up the middle. You're gonna get this, right? But is this, can we have OH in our salt? Can you have H plus in your salt? No, right? So if you ever go through something like this, I know what I usually do is I'd be like, oh shit, I have OH and I can't have that in my salt, so I boxed it up wrong. So what I would do is I would rewrite it in a different order. So instead of having NH4 at the end, I just write it in a different order. I just swap them, put this here, put this here. Now let me try boxing it up. I'd get KNO3, potassium nitrate. Chemical formula is this. Because by the way, it's K plus and NO3 is NO3 minus. Crisscross, you get KNO3. Please don't be the person that writes NO3K. Please, yani, obviously this is the anion, because it's the second one. And this is the cation. So it should be the first one. So it should be the cation should be first, anion should be second. And well, don't get this stupid mistake. Okay. So we boxed up, we wrote our salt. Very easy. And they said that a gas was produced. And you guys know when you have an ammonium salt reacting, that gas is always ammonia. It's NH3. Okay, so it's ammonia, NH3. And they said, right, and that ionic, ya Allah. Okay, so we're gonna write it fast. KOH was an aqueous. NH4NO3, obviously aqueous. To produce a salt, what was our salt? We said it's KNO3, which should be as also aqueous. Plus, what do we say? Water, H2O, liquid. Plus the gas, NH3, gas. Let's see. K aqueous, K aqueous. We don't want. OH aqueous turned into water liquid. So are we going to take it down? Of course we will. And here we're going to put H2O liquid. Done. NH4 turned into NH3. It was aqueous, became a gas. So are we going to put it? Of course we will. The charge of NH4 is plus, by the way. Okay, done. Done. NO3 aqueous, NO3 aqueous. So we're not going to take it. So I should have written NH3. I don't know why I didn't write it. So this is our net ionic. The order, by the way, doesn't matter. You can write this first or this first. Whatever you prefer. Okay, question 7. Oh my god. Okay, lithium hydroxide reacts with sulfuric acid to give a salt and liquid. So this is a base hydroxide, right? A base hydroxide. And this is an acid, sulfuric acid, to give a salt and a liquid. Okay, so obviously you're reacting an acid with a basic hydroxide. So remember, acid plus basic hydroxide, or by the way, metal hydroxide, because lithium is a metal, metal hydroxide, whatever you want to call it, it's always going to get you a salt and water. So what's our acid? H2SO4, because here they asked to find the salt. I'm just writing it in a way so that when you box up the middle, you get the salt. Always write acid plus, always write the acid first if you have acid, okay? Plus basic metal hydroxide, LiOH, to form the salt. What's our salt? Box up the middle, you get this. Li is plus because it's group 1. SO4 we know is 2 minus. Crisscross, you're going to get Li2 SO4. So you get Li2 SO4, which is obviously aqueous, plus the water, which is liquid. Okay, I'm just gonna write the states from now because I think they asked for net ionic. Yeah. They said non-ionic. Oh, okay. Okay. Anyway, you need this. Obviously aqueous. Okay, what is the salt formed? Lithium, this time sulfate with an A because it's SO4. Okay, what's the formula? We found it, Li2SO4. Easy. No gas produced, so they didn't ask about the gas. They said non-ionic. Non-ionic basically means what? Just write the normal reaction. What's the reaction? It's this, H2SO4. We wrote it up. I just want to make it a bit more clear. Aqueous plus LiOH, also aqueous, to produce Li2SO4, which is also aqueous, and H2O, liquid. Please check if it's balanced. You have two lithiums here, so here you should have two lithiums. Okay, 2OH. So let's see, 2H2Os. Here you have you have 5 oxygens. Here you have 6 oxygens. So you have 5 here. So yeah, you would multiply this by 2. So now you have 4 hydrogens. Yeah, because you had 2 hydrogens here, 2 hydrogens here, so it's 4 here. And you only had 2 here. So to make this 4, you multiply by 2. Now check if it's balanced. 4 hydrogen, balanced. SO4, balanced. 2Li, 1, you have 2 oxygens here, 4 oxygens here, so 6 oxygens. So you have 4 oxygens here, 2 oxygens here, so also 6 oxygens, so this is balanced. Okay, check, compare it, it should be the same thing. Yes, it is. Okay. Question 8. Okay, these 3 methods are used for salt preparations. Method A, B, and C. A is using a burette and an indicator. This is obviously titration. When you use a burette and indicate, that's titration. Mixing 2 solutions to obtain salt. This is precipitation method. Just whatever, precipitation method. Addition of an excess base. This is the excess method. Remember our methods, what were they? To prepare salts, you can have soluble or insoluble. Insoluble, you only have the precipitation method. For soluble, you have the titration and the excess method. Okay, I explained this for week 8, chemistry CA. If you really want to go, if you're clueless, go back and watch it. I explained it very well. Go back and watch it. Here, question 1, they said choose the correct answer. They want to prepare soluble salt, magnesium chloride. They said soluble salt. So quickly, you go to method B. We don't want that. Okay. From the insoluble base magnesium oxide. Some people, they're still confused. How do I know if I use titration or excess? You ask yourself, is the base I'm using soluble? If it's soluble, بتروح at titration. You go use titration. But if it's insoluble, you're going to use excess method. They said insoluble, so you're going to use excess method, so it's method C. The reagent used is what? Okay, there's basically, what do you have to add? They want to produce magnesium chloride, which is MgCl2. Because, by the way, Mg2 plus Cl minus crisscross MgCl2. From the insoluble base magnesium oxide, so you're adding MgO. Okay, MgO. We want to see what do we have to add. طيب. Magnesium. We got the magnesium. I need a chlorine. Obviously, by the way, guys, we need to add an acid, صح? We need to add an acid. We're adding, what do you always, like, to prepare in the excess method is always acid plus something. Or, in the only case we use base is if you have ammonium salt, but we don't have any ammonium salt here. So, akid, we want to add an acid, so it should be something with hydrogen, right? Hydrogen what? Let's see, Mg, we got it from here. but the Cl, we're missing a Cl. So we need to add something with Cl. Which acid has H and Cl? HCl. ما بدها هالقد. And then complete the equation of the reaction. Oh, so it's just this. Okay, yeah, I guess that makes sense. Oh, and then they put the 2, so you have to know, okay, this is our reaction here, HCl plus MgO to produce MgCl2. Obviously, guys, you're reacting an acid. This isn't the complete reaction. I just wanted to show you what's happening. You have an acid with a metal oxide. What happens? You get obviously the salt, but you also get water, صح? Like, remember? Okay, so this is the full reaction. Let's see if it's balanced. Mg, Cl, Cl2, so you need the 2 here. Hydrogen 2 here, balanced. Okay, yes, so this should be balanced. So let's see. The one that has 2 beside it, we're going to put HCl. What's left? MgO. And they wrote for you H2O, so you're going to put MgCl2. These questions, really, they're very easy, guys, but you really need to focus, and they need some thinking. The best method to obtain ZnSO4 when H2SO4 reacts with ZnO is what? Okay, let's see. When you react an acid with a metal oxide, right? Metal oxide. What do you get? You get salt and water. For those who don't know, the salt is aqueous, meaning it's dissolved in the water. And مثلا this would be water, but it would be this is aqueous. Let's say we're obtaining ZnSO4, so it's going to be ZnSO4 aqueous. طب I have zinc sulfate. It's dissolved in water. How do I obtain the solid version of it? بتروح تاخدها and you perform crystallization, right? Did they say anything else? Evaporate. Okay, crystallization is better. Memorize crystallization. This will definitely come in your written part. I'm telling you from now. They're going to give you something about salt preparation, and they're going to say, how do you obtain the crystals? You're going to say you perform crystallization. And then they might ask, I saw in one of the past paper questions, they asked, describe the method to obtain it, and it's 3 marks. So you obviously just saying crystallization is not enough. You have to say put it in an evaporating dish, heat whatever, heat it directly until when most of the solution evaporated. You have to properly explain it. So in the notes, chapter 3 notes, which I highly recommend you to go over and solve, to crystallize. It's not here, right? Here, somewhere. Where is it? Okay. To crystallize, you heat the solution. So this is like they say describe. You write this all here. Okay. Actually, no, hatta this part at the bottom. This is all important. Okay. You should know all of this. Okay. To crystallize the salt, you heat the solution in an evaporating dish directly on a flame till most of it evaporates. When most of it evaporates, you put it over a steam bath. Why do you change it from flame to steam bath? Because steam bath won't burn your plate, okay? This is how I memorized it. Okay, now with steam bath, heat gently till the crystallization point, so till the solution is saturated. So like, خلاص, there's no more liquid there, you know? How do you know? They say, sometimes they ask, how do you know that you have reached the crystallization point? You dip a cold glass rod in the solution. It has to be cold, not warm, cold, okay? If crystals stick to the cold glass rod, then that means it's still not saturated, okay? You should be no crystals formed, I think. Yeah. Okay, so leave to cool, filter off the crystal. Yeah, if there's crystals formed, whatever, leave this. Wait, okay. My bad. If the cold glass rod is dipped and crystals formed, that means you reach the saturation point. That means خلاص, and it's time for you to continue with the next step. We found out that the solution is saturated. We checked it's saturated by dipping a glass rod in it, and crystals formed on the glass rod. What do you do now? You leave the solution to cool. It was hot, right? You leave it to cool, and you filter off the crystals. You perform filtration, because now هلا it's a saturated solution. What do you mean by saturated solution? That means it's a solution that خلاص, if you add more, it won't dissolve. Like, do you get what you guys know what saturated means, huh? And if you add more, like مثلا sugar and water, you can't just keep on adding sugar and it's going to dissolve. Eventually, the solution is going to become saturated, and the more sugar you add, it won't dissolve. So basically, now you know it's saturated. So you leave it to cool, and you just filter off the crystals, and then you dry the crystals because they were obviously wet, whatever. If you still don't understand, think about if any of you have made coffee before, you have probably realized that when it's hot, and like when it's boiling, whatever, and you add sugar and you mix it, the sugar will dissolve عادي. But then you leave your coffee on the table or whatever for like a good 5 minutes, and you're going to drink. وتلاحظ, oh, what happened? The sugar, it's not dissolved in the coffee anymore. Like it like it rose to the top now. So that is basically what's happening here, and or sinks or whatever. I don't know, but you'll see it in crystal form. That's what's happening here. You made it saturated at a hot temperature. Saturate, خلاص, it won't dissolve. Then if you cool it, أكيد there's gonna be crystals that form, and then you filter them. Okay, think of it like the coffee thing. Okay, you filter it and then you dry the crystals, whatever. This is a crystallization method. Make sure to know this for your written part. Okay, 5 steps to crystallize: heat an evaporating dish directly over a flame until most of the liquid evaporates. Then transfer to steam bath until solution is saturated. It can be checked by dipping a cold glass rod and seeing if crystals form on the glass rod. If crystals form on the glass rod, that means the solution is saturated. Then leave the solution to cool. After leaving it to cool, perform filtration and then dry it off with open air, without pressing or in open air. Dry it off in open air. Okay, dry the crystals with 2 filter papers in open air. Question 10. A mixture of NH4NO3 and NaOH are heated. A gas with a pungent smell is released. What is the pungent smell? Guys, you all know that's NH3. Okay, obviously because you have a base. This is the base, and this is the ammonium salt. I'll just put a salt. Ammonium salt with base. You guys know that's a way of the excess method, right? طيب. What does this gas turn? Obviously, it turns red litmus paper into blue, right? NH3. And it's ammonia gas. Very simple, easy question. Let's hope question 11 is easy as well. To prepare PbSO4 salt, equal quantities of what and what are mixed in water. PbSO4 is insoluble. If you go to our solubility rules here, SO4 is always soluble except with barium, calcium, and Pb. Okay? Because these all form white precipitate with SO4, by the way. Because you need this for topic 11, the chemical analysis. You need it for this. So, you want an insoluble salt. So what method are you using? Precipitation method. What do you need for precipitation method? You need 2 soluble aqueous solutions. They don't have to be salts as long as they're aqueous. Let's see. PbNO3, it has NO3. You guys know anything with NO3 is always soluble. So if you have anything with NO3, then you're going to pick that. And then Na2SO4. Anything with sodium is always soluble. So these two are both soluble. So you choose the soluble answers and you mix them together and you're going to get an insoluble salt. What is this called? The precipitation method or precipitation reaction. Okay? Before ending the recording, here, if you have magnesium chloride, like for this question to prepare magnesium chloride, so they wanted MgCl2. We said this, right? MgO. It's a metal oxide, so you need to add an acid, and we said it has Cl. So obviously you would add HCl. Let's say it was magnesium sulfate. Okay? In case they bring this. Magnesium sulfate. If it was magnesium sulfate, obviously we're going to have to add SO4. And it's an acid, so you have to add H. If you write it like this, you're going to get X. Why? Do we have any acid HSO4? No, it has to be H2SO4. So please pay attention for this. If you have SO4 and you want an acid with it, it has to be H2 because sulfuric acid is H2SO4. And one last thing before I end this recording. If you're doing acid plus metal, the 2 metals you cannot use are Cu and Ag. You're not allowed to put them. Okay? I remember in the exam, it came like which ones can you add to an acid for the excess method, and it was Mg, MgO, MgOH, and then MgCO3. Okay? They were all correct. Some people did not choose Mg because in the quiz they put Cu. Okay, and then people were like, oh, Cu alone is wrong, and Mg alone is wrong, and they got it wrong in the exam. No, yahi, of course it's correct. Why was Cu wrong? Because Cu and Ag, they're not allowed to be alone. Okay, they need to be with something else because they have very little reactivity. Okay. After this, I'm pretty much done. But there's a titration method, but that's for 3.5 if I'm not wrong. I'm gonna include 3.4. I'll do 3.4 because it's one question. Okay, guys. 3.4 class 1 question. This is what we like to see in chemistry. A compound is said to be stable in chemistry if it has low potential energy. Is this what else? What is 3.4 about? The nature of H plus. The nature of it. I don't want to know, guys. I think it's on this page. One sec. I'll cut to when it loads. Oh, it loaded. Okay. Okay, yeah, here, the blue text. Okay, no, go back, go back. Okay, very stable means that LiCl has a low potential energy, so it requires a lot of heating to provide kinetic energy. La 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 la. So if something is stable, it has low potential energy. So it requires a lot of energy. Oh, that's a lot of, that's a lot. Oh, that's a lot. Oh, yeah, guys, skip all this. Skip all this, skip all this. Um, yeah, just it's one question, so like sigma. Okay. Thank you so much for watching. Good luck.